Perfect. Thank you very much. I'll share my screen. Cool.
Great.
Yeah. So, hello everyone. I'm super excited to be here today. So thank you very much for the introduction and the invitation. I see that there's a lot going on in your community. That's very nice to see. So today I'm going to give a talk about dask-sql, a new Python package in the Dask ecosystem, which is a SQL query layer for Dask. And so the first thing, of course, I want to do is introduce to you what a SQL query layer is, and then a bit about Dask, and then, of course, also what dask-sql can help you with. So a bit about myself. I'm Nils. Hi. So I'm the developer of TS Fresh and dask-sql. TS Fresh, in case you don't know it, is a time series feature extraction library also for Python. So you can use it for automated feature extraction on time series and also feature selection. As Aaron said, I used to work as a data scientist. Now I'm a data engineer. So I know those two worlds. And currently I'm working at Bosch, at the Bosch Center for Artificial Intelligence. And I'm a trainer for data engineering there. So I will later also tweet about my slides. So if you want, you can follow me on Twitter and then also get the link to those slides here and also to the code that I will show. Yeah, so let's introduce dask-sql and SQL query engines or query layers. So as I've heard, you're coming from different backgrounds, which is super interesting. And now let's maybe try to put ourselves into the shoes of this data analyst here. So this data analyst has the job to analyze the data of his company and then also to apply transformations and maybe machine learning to this data. And if you're now starting with a very naive approach, this is actually quite complicated. Because if you're a data engineer, you might know the problem is you have data from different data sources. You have data from sources that are very uncommon, maybe inhomogeneous. You have a lot of data that you need to care about, and distributed computation is quite complicated. So maybe you want to start quite simple and just ask your data engineer, well, please give me the data in Excel files. That might work for some use cases, but of course, this also has quite many drawbacks. So it's simple, but it does not scale very well, both in terms of data, but also in terms of iteration times. Whenever you want new data, you have to go back to your data engineer again. So let's improve this. Let's go to possibility number 2. We ask now our data engineer for data dumps in the database. This is much better because this might even be automated, an automated pipeline there to aggregate the data from the raw data sources to the database. And this time we can start to use SQL. This is nice because SQL is a language that allows us to translate our quite complicated queries and complicated transformations into something which is quite simple. And we can even use our BI tools, for example, Apache U or Power BI or Metabase to connect to those SQL databases. And the problem is we can only put aggregated data into this SQL database because typically you have a lot of data in your company and this does not fit well in the relational databases. And still, if you want to have different columns, different data in your data dumps, you still need to go back to your data engineer and ask for updates. Okay, so let's also improve with that. We use a SQL query engine. So what is a SQL query engine? We start again with the raw data. So when I say raw data, I actually mean data stored on things like S3 in the cloud, maybe on HDFS, the Hadoop distributed file system, or could even be local disks in your cluster. And this data is distributed among many machines because it's big data, because it's complicated data. And that's why on top of that, we put a distributed computation engine. That could be things like Spark, could be things like MapReduce, or later we'll see that could also be Dask. And then we use a cluster maybe a Kubernetes cluster or a cluster in the cloud to distribute this computation. But writing and maintaining those distributed computations, this is complicated. This is hard. So that's now the point where SQL query engines enter the game. They are something like a layer on top of the distributed computation framework. And they translate SQL from the user into those complicated distributed computation. So for example, you might have heard about Hive, Impala, or Presto. They are all SQL query engines, and they use the SQL from the user and then give this to the distributed computation engine on the cluster. So you can query the data with SQL now, and also if the data is a lot, you can still use SQL. That's super nice. It still connects with your BI tools, and you can really leverage the full power of your cluster. This is very good. Now, unfortunately, there's still a drawback. And this drawback is that these are typically Java applications. So they do not connect well with the data scientist's world. So for example, things like machine learning, or maybe just if you have certain transformations already coded in Python. So it's very hard to use them in those SQL query engines. And they are built for the usual data formats like Parquet or CSV files. But if you have a more complicated data format, they don't play very well. Okay, so what do we do? Well, we just use Python as a SQL query engine. So the concept is still the same, but this time we use a Python framework for our computation. And this Python framework is, of course, Dask. In a few slides, I will tell you more about what Dask is. But there are 3 SQL query engines around, probably even more, but at least 3 that I'm aware of. One is dask-sql, one is blazing SQL, and one is Fugue. The idea in dask-sql, for example, is really use the SQL from the user as a string, then parse it. dask-sql is using Apache Calcite for that, but it doesn't really matter. At the end, the SQL gets parsed and then converted to Python code. And this Python code is then executed on the cluster and can access, similar to other SQL query engines, the data on your distributed storage like S3, HDFS, or things like Hive. So I did mention Dask now, so let's introduce it. Dask is similar to Spark for the Java world, a distributed engine. It helps to scale up your Python code because it integrates very well with the rest of the Python ecosystem, and especially the numeric Python ecosystem, things like pandas or NumPy. So on the first code example, you can see on the left side Python code to read in a CSV file and then do some group by and some aggregation. But on the right-hand side, you can see the corresponding Dask code. It looks quite similar. That's, of course, for a reason. But there's really a large difference between those 2 code examples. The left one, the pandas one, runs on your single machine, just on your local machine. And the right one can scale to the full cluster that you have. So Dask gives you the opportunity to use those so-called high-level view. So you can create data frames, you can create something like distributed lists, you can create arrays and do calculations on them with the API that you probably know from pandas or NumPy, but using distributed calculations. Dask comes also with a low-layer distributed engine, which means it comes with a scheduler, it comes with means to distribute certain functions to your cluster if you want to really dig deep into your distributed computation. And that also helps other packages. For example, here you see it has integration with XGBoost. That's the second code example, but also integrates very well with sklearn, with things like Keras, TensorFlow, PyTorch. So there are integrations and combinations with Dask. And last but not least, it also is the basis for Rapids, the Rapids ecosystem, and help scale them to larger clusters of GPUs. So it can also be used in GPU calculations with the Rapids ecosystem. So Dask allows us now to keep the Python ecosystem that we love and also integrate the things that we use every day, like scikit-learn or XGBoost, and still have a distributed engine to run our calculation in the cloud or on a cluster. And the way it works is shown here in this graph. It starts with those high-level collections like data frames, and out of the things that you do with the data frame, for example, you do a group by, you do some aggregation, it creates a task graph. So in this task graph, it specifies what should be done on the data. So whenever you call a group by or a mean on your data frame in Dask, it will actually not do the calculation right away, but it will create this task graph where you have a node where it says build the mean. Simplified. And this task graph is then sent to the cluster and distributed among the machines. And that's the reason why Dask can scale so well to a large number of machines. Now we have a mean to use Python as a SQL query engine. And what's now the benefit of that? Well, the benefit is that you can use in the same code both the Python API that you know from pandas, so quite similar to pandas, and also SQL. So you can do some transformations which are easier to do in pandas with the pandas API in Python, and then you can just mix them with SQL statements. So here in the code example, you can see some things which are quite similar to pandas. So this reads CSV here, for example. But then you can also see there's a SQL statement in between that does some aggregations and group by. And I will come to the API of dask-sql in a minute. I just want to say, of course, you can also use it like your normal SQL query engine. So in the background, you can see this is Apache U, one of these BI tools which are used heavily also in industry. And this actually has a dask-sql integration. So you can write, go ahead, start Apache U and connect to your dask-sql cluster. So let's summarize that. With a Python query engine, and dask-sql would be one example for that, you can still use SQL, but you can also connect with the rest of the Python ecosystem, for example, for machine learning or other integrations. The drawbacks of dask-sql in particular is dask-sql is still a very young project. So I really need to say this. It's super young. It's just a few months old. It's definitely not battle tested compared to those other SQL query engines. And that's also a reason why just a part of SQL is implemented so far. But it's open source, so I'm always happy for contributions, of course. I did mention that there's not just dask-sql. So dask-sql is one Python SQL query engine, but there's also Blazing SQL and Fugue. There was a talk on Blazing SQL in the past, also in this PyData meetup. So let me quickly repeat what Blazing SQL does. Blazing SQL is a SQL query engine built for GPUs. So it only runs on GPUs, but it is really, as the name says, blazingly fast. So the use case would be if you have a lot of data that you want to run on and you have access to a large GPU cluster. The nice thing is that Blazing SQL actually shares its API with dask-sql, so we collaborated on that. So you can really switch between those two. For example, if you want to test something local, you can use dask-sql. If you want to test something on your CPU cluster, you can use dask-sql. And if you then want to go really, really big and have access to GPUs, you can just switch this to Blazing SQL and go ahead. And yes, they have a cool logo, and dask-sql still does not have one. And then there's Fugue. I'm not sure if everyone knows already about Fugue. So I learned just recently about it. Fugue tries to build a common framework for SQL and also non-SQL Python code to run on Dask or Spark or native backends. So you can just switch the back end and your code stays the same, and then the calculation runs on Dask or on Spark or natively on your local machine. So I'm currently collaborating with the Fugue authors to really get dask-sql as the SQL backend for Dask in Fugue. But it's really a cool project. So here's a code example for that from Fugue. So this has nothing to do with dask-sql, but Fugue. So it's actually using dask-sql in the background. But what you see here is it's kind of SQL code. So you have your select statement here. But it also has variable assignment. So you can assign your select statements to variables and then use those variables here. And you can also, for example, introduce those Python functions. And by just switching this Dask execution engine to a Spark execution engine, this code will run out of the box on Spark, which is really nice. And of course, it has all the nice things like you can load data and store data. And yeah, use basically everything that you know also from SQL. Okay, so let me go, sorry, one back. So again, Fugue, you can use it for if you want to switch between Dask and Spark, and it also uses dask-sql in the background. But if you want to stay local and you have access to maybe a Dask cluster, you can also use dask-sql, because it also has some nice things that we will later see also in the demo. All right, that's actually already time for demos. So
we actually do have one question, Nils.
Yes.
Actually, if you want to answer it before the demo.
Yeah.
Ravi was asking, will dask-sql need to be installed on every worker node on a Hadoop / or Hive data lake for it to be used in the distributed computing environment?
That's a very good question. So actually, no. So dask-sql only needs to be installed on one machine where you can connect to. So dask-sql has both, as I said, it has a SQL interface, so it's just a port. It uses the Presto protocol to speak with your BI tool. So you only needed to have this server run once, or if you just use it from your local computer, from your Jupyter notebook, I don't know, you just need to have it installed there. So what it will do, it will parse the SQL, and then we'll send just the Dask computation graph, this task graph that I was talking about, to the cluster. So on those worker machines, dask-sql does not need to be installed. They don't know that the statements come from SQL. They just see the Dask computation graph and do their normal stuff, as you would call if you just code df.groupby, something like this.
That's really cool, and that's handy, especially if people have like big clusters already set with environments. You just have to install it on your client. There is one more question from Michael. Is the API for Dask versus Blazing the same as if like you would swap imports, or is it the same API with like a common set of interfaces?
It's the like the swap import thing. So yeah, maybe we'll see it later in the demo. There's a context object in dask-sql, and there's a context object in Blazing SQL, and they do share the same API. So if you have code that does something with this context object, they can just switch this from Blazing SQL or to dask-sql. But yeah, that's the what happens in the end is actually quite different. They both use Apache Calcite, but then Blazing SQL uses CUDA C++ code to do the calculations, and dask-sql is using Dask Python code to do the calculations. All right. More questions? If not, I will switch to demo. But of course, feel free to just ask more questions if you want. Okay, is this large enough? Should I maybe zoom in to the notebook? We first will just need the notebook. Okay.
Looks good on my side.
Very good. So I just spin up here in Jupyter Lab with a Jupyter notebook here. And what I did, I started with some imports. So dask-sql, as I said, it has this context object. And the reason for having this context object is this is basically where you store and register the tables that you have. So everything in SQL is around tables. So you need to tell dask-sql, when I say table A, then I speak about this amount of data and these things in these columns. That's the reason for this context. What I also did, I spin up a local Dask cluster. So if you have never heard of Dask, you can just keep it as it is. If you know about Dask, then you probably know that you can very easily switch this to connect to your cluster, to your cloud cluster, or maybe your Kubernetes cluster, or things like this. But here I just have a local cluster running with just 4 workers. And on the right-hand side here, you see the cluster dashboard, which basically, can tell us later what is going on our cluster. So here's the first SQL that I will call this evening. It's just a method of the context, and you can just give it the SQL code as string. And what it will do, it will send this calculation. The cluster will, this is very easy calculation. There's actually nothing going on here. Because it's just a constant, and it will return us a pandas data frame in this case. But if you turn this to true, which is the default, it will return us a dask data frame, which is still this computation task graph that you can then send out to your cluster. So this computation has already happened on the cluster. And the next code is just for a bit better visibility, so that I can just write SQL here as a shortcut, and it will do exactly the same thing as here. And this is the thing that I will use in the following. Again, I'm now showing you the Python API, but you can do the same things also from your BI tool and just do those SQL select calls directly to your Dask SQL server. Okay, so when we want to do something on data, we first need data. So we need to import data. And there's 3 methods to do this in Dask SQL. The first thing is you start with a Dask data frame. So maybe you have already a Dask data frame. Maybe you create one by reading data from CSV. So here I'm using, of course, the Iris data set. I guess you all know it. And I'm creating a new data frame out of that. And as I said, the Dask data frame is really similar to a pandas data frame. So here's the head method, and it will show me the first 10 lines. So I guess you know we have these different species here of iris flowers, and then we have some features of that. And now we just need to tell Dask SQL that we actually have this table and we want to give it a name. And this is done with this create table method here. And from now on, whenever I say iris in my SQL statements, then Dask SQL knows, aha, I'm referring to this data frame here that I've registered there. You can do the same thing directly from SQL. So there's a create table method in Dask SQL. I just give it the same name and I tell it, okay, use this file location, format CSV, and also persist it, which means cache it. The nice thing is here, again, it's Python, it's Dask. So you can immediately use the very huge Dask ecosystem for that. So Dask has integrations for S3, for many things on the Azure ecosystem. Also now coming, Ray knows about it, hopefully soon DBFS, so Databricks file system, Google storage, HDFS, a lot of other things. You can connect to your Hive cluster. You can hopefully soon connect to your Databricks cluster. You can connect to your intake catalog. So as the Python ecosystem is so large, this is really immediately here available to you. And last but not least, you can, as you can do in many SQL engines, also create those materialized queries. So from one statement, you can create a table, maybe like as a shortcut, and I will use this a lot in the following. And here you see there was actually something going on, but there was really just a small lookup, so not a lot on our cluster so far. Yeah, two small helper methods. It has the typical SQL methods implemented. You can list the tables. So we have two currently. You can list the columns of a table. So it's the same information again, but quite useful if you only have the SQL interface to that. Okay, to showcase you what dask-sql can do, I will just show you a few quite simple SQL statements. So as I said, dask-sql tries to implement a lot of SQL, but SQL unfortunately is quite large. So there's a lot of translation that needs to be done, but a large fraction is already implemented. So of course you could do the quite simple select statements here, the first 10 items. You can do more complicated things like you can add two columns, you can give it a different name, you can call the sinus on the petal length, although that probably does not make sense a lot. That will work. And here on the right-hand side, you can see whenever I issue such a command, there's a small calculation going on our cluster. Not a lot, because also data is, of course, very small in this case. You can do group bys and aggregations. And this one is a bit more to do. And you can also do quite complicated things. So if you know SQL, maybe you're quite fast here. There's one table defined, maximum values, which is just the maximum species, the maximum sepal length per species. And then I collect here all those values where those maximum, where the sepal length is actually maximal. So I do a join here and a group by, and all of this runs on dask-sql. If you're interested what happens behind that, there's an explain method, and it will basically tell you what it will do. So this statement here was given to Apache Calcite, and then Calcite gives us this this nice output here, which basically tells us what do we need to do one after the other. So it starts from the bottom. It starts with the table iris, then it does a project, which means it only gets certain columns of that, and then does it aggregate, and so on and so on. And the job of dask-sql is basically just to translate those calls into Dask API calls. Okay, so now, so far, everything is quite standard. So most SQL query engines can probably also do that. Now to things that really are good when you have a Python SQL query engine. And that is, you can use your Python functions. So maybe you have a complicated transformation function. So here I have a function to calculate the volume, which is not so complicated. Probably I can do this also in SQL, but just to showcase here. So I have a Python function. I register it as at my context. I need to give it some type information because SQL is a typed language. So I need to tell it that I have floats as the return type and also expecting floats as my input parameters. And from that on, I can use this iris volume that I've registered here. And as everything is Python, there's really no drawback, no performance penalty here. So there's no translation happening. This really is calling the Python function. And inside this Python function, you can do whatever you want. So you can even put in, I don't know, an API call, or maybe connect to your second data source, which is not able to handle in SQL, things like this. Or you can put in machine learning into those functions. So in principle, you could here in this return function just call your scikit-learn model or a TensorFlow model and get a prediction, and then use this directly in your SQL statements and aggregate and do some calculations. And as this is such a common pattern here, this is actually already built in directly into dask-sql. So here we have a bit more complicated SQL statement. So I want to do machine learning. So I have to start with feature engineering. I will create one one new table here called enriched iris, and I will use the columns from before, the sepal length, the width, the petal length and width, and also my volume that I've calculated before, and I will turn my my species into a integer, so 0, 1, or 2. So now I've done feature engineering. So if you want to have a look, select star from my enriched iris, limit 10. Here you go. So I have the same columns as before, plus my additional volume here. And now the next step in machine learning is, of course, I want to do a train test split. So I'm using a table sample SQL method here, which in this case splits it at 50%. And I'm storing this in the training data. So the training data looks like this now. It's shorter than the full data, and it's also shuffled a bit. And now I can train a machine learning model on top of that. So there's a SQL statement in dask-sql, which is called create model. And I can just give it a reference to a Python method. So a normal Python machine learning model. So I'm using an XGBoost machine learning model here, the XGB classifier. I tell it that I have 3 classes, and I tell it that it should train on the species column, and that's it. And what it will do in the background, now this one is a bit more complicated, of course, this calculation. It will fetch the data, and it will then send the data to the classifier, and as everything is Python, it will work out nicely. So I can now predict with this model. So I predict with this created model here, this is my model, using my full data sample, and this will look like this. So I end up again with the same columns, but now there's an additional one, which is called target. And this is now the output of my prediction. And for example, I can now start to see how well the method did. So for example, I can create a temporary results table with these inputs. And now, I don't know, aggregate on the species and count how often I have seen which predicted label. So this is the result. So here you see what was the real species. Here you see the predicted label, and you see it's not a one-on-one correspondence, or probably not super well trained, but this is just an example. And again, this is Python. So this is a pandas data frame. So you can use matplotlib to just plot what the output here, and see directly the distribution of those target variables and the trained variables. So this is really the nice thing. You can mix and match Python code with SQL code and basically use them vice versa in the others. Okay, so this is already the end of the demo. I have intentionally used my local machine here because I don't want to trust the cloud for this demo. But by just switching the local cluster to your distributed cluster, this will scale to a lot of machines and to a large data sample if you want. Are there questions to the demo? So I see that there are some coming up in the chat.
Yeah, there's one question. That is it possible to query data stored in NoSQL databases, e.g. Cassandra?
Mm-hmm. Yeah, very good question. So in the end, as long as there's a dask integration for that, you can basically use it directly from dask-sql. So for example, I'm not sure about Cassandra, but I know that there's an Elasticsearch integration. Just to give an example for NoSQL database, there's an Elasticsearch dask integration. So you can turn Elasticsearch data into your dask data frame, and then you can also use this in your dask-sql query.
Gotcha. Nice. There's another question here, I think related to the machine learning capabilities in dask-sql. somebody's asking about like hyperparameter tuning. Didn't see any of that in the SQL. Does it support that, or is it on the roadmap?
So dask-sql supports machine learning really from the release, which was released, I think, I released it 2 days ago. So it's super new. But I definitely want to improve on that. So definitely want to put more features in there. So the syntax is already similar to Google's BigQuery syntax, and they have also syntax for hyperparameter tuning. And Dask has a lot of packages for hyperparameter tuning. So it's not implemented so far, but that would be a very nice feature addition. Yeah.
Cool. Another question, comparing like dask-sql and blazing SQL. You mentioned like it can be faster. Someone's asking if GPUs are really helpful for a SQL query engine.
So I did not, but the blazing SQL guys, they did. But of course, that might be a bit biased. They have some very impressive numbers, so that you can also find on their website. And I did not so far test with the same amount of data and on large clusters, but in general, they did really well in implementing those aggregations or calculations, and they are really fast. But if you want to scale to many machines, and for example, also to like very inhomogeneous clusters, then Dask is really better and shines.
That makes sense, definitely. Ray's asking something that I was actually curious about too, is how would people want, if people wanted to get started and get involved helping out with dask-sql, where's the best place to get started?
Yeah, so I do have still like 3 slides, and this I will cover there. Very good question.
Great. Getting ahead. I actually did have one question, like related to like building and developing this project. You mentioned Apache Calcite is used for like the SQL translation. Was that like a decision from the beginning, or did you try kind of thinking about writing the translation yourself and then moved over to there? How did that go?
Very good question. So let me just scroll up a bit to the output of basically Apache Calcite. No, that was too much. So when I started with dask-sql, as I said in my like a free time project, I actually thought, well, SQL is not so hard to understand, so that should be quite easy to write a parser for that. And parsing SQL is not explicitly the problem. The problem is that you can do a lot of optimizations even already on the SQL code. For example, by only calculating the same calculation once. So in this join here, I might reference the same thing that I have in my select call here and these things. And I don't want to calculate them twice, of course, things like this. Or there's a lot of optimization going on. How do I join 2 things together? And these are things which are already built in Apache Calcite. So that's why I quite quickly moved to Apache Calcite. Also, blazing SQL is using Apache Calcite, so that's how I learned about that. And they do a lot of optimizations already. There's more things that could be done here, but they already built a quite optimized graph, which I then just need to translate.
Awesome. And it's great that they built the project to be pluggable to others.
Super nice. I mean, it's Java, but there are also like Java Python integrations. So JPipe I use here, and it works quite well.
And then that again only needs to be on your client, right? You don't have to, if your workers don't have Java, then you don't need it. Looks like we've got a couple more questions. Bob's asking, does the create table function copy data is one, and then how does dask-sql handle shared slices within data frames?
So the create table function does not copy data. So everything in Dask is basically a reference to this task graph. So Dask only stores information. I do have data, and I have these column names with this type, but it does not fetch the data so far. So also dask-sql only handles these references to the data. And only when you basically hit the compute button, it will start to go to your data and do the calculation. If you want, as I have done so when I created the first one here, You can tell dask to cache the data, so then it will start loading it into memory. But this is not mandatory. And then the second question was, how does dask-sql handle shared slices within data frames? So I guess you mean things like partitions. So this is handled by dask. So dask parallelizes via those partitions. So it splits up the data into different chunks and then runs the calculation on those chunks. And dask-sql using dask does the same.
Great. There's a question here about integrating with like deep learning frameworks like TensorFlow, Keras. Is it possible even though the deep learning is potentially done outside of dask-sql?
So in principle, whenever you have a machine learning model which has the same API as the scikit-learn estimators, you can in principle use this directly in dask-sql. Probably you don't want to do that because deep learning frameworks tend to have a lot more options that you want to tune. Maybe you also want to tune how you train exactly, how your optimization is. So probably you want to maybe prepare your data in dask-sql, do some pre-aggregations, and then use the output, the dask data frame, or maybe even turn this into a pandas data frame and then do the calculation in your deep learning framework.
That makes sense. Anybody else have any questions? Add them in the chat.
If not, I would show my last few slides with some more links, and then we're done. Okay.
Definitely. Anybody has any last minute ones, get your questions in, and then Nils could answer them before we break.
Okay, so demo is over. So let me just summarize what we've seen. dask-sql is really, as the name says, it's dask on the one hand side and SQL on the other side. So dask means scaling Python. So we can directly use the large ecosystem of open source, data, tooling, Python, many well-known tools, for example, in machine learning, and at the same time distributed. So and the SQL part means opening the ways to many applications. As SQL is heavily used for data analysts, which might not even know Python, they can now start using the Python ecosystem with that. And it also connects with many different applications. So as Aaron said, I was working as a data scientist and data engineer. So this is really nice because it simplifies the collaboration between data analysts, data scientists, and data engineers. If you want to start using it, here are some links. So there's documentation up, and dask-sql itself is really just a conda package. You can install it with conda or pip if you want, but I would recommend conda because of the Java dependencies. And if you're new to Dask, then there's also a lot of Dask documentation here. So they also have very nice documentation up and running. And there I also had some Medium articles which explain a bit of an introduction and also how you would deploy dask-sql on a larger cluster with Kubernetes, for example. There's also a cold article. And as you've seen, I mentioned other SQL engines like Blazing SQL and Fugue, and they also are linked here. Yeah, so that was my talk. Very happy for all of those questions, and thank you very much for listening. Yeah, if you have more questions, I'm happy to answer them now.
Thank you very much, Nils. I definitely learned a lot, and I think the format of the talk was great, and the demo was really concise. We have one more question. The question is asking specifically about if Dask has something similar to like HyperOpt and Spark, but I kind of maybe will make that a little bit more broad because there's HyperOpt, there's Optuna, Hyperband, like Dask has its own stuff. You know, what does kind of the integrations look like there for hyperparameter tuning?
So Ray already mentioned Dask Optuna, which is like the integration of Optuna into Dask. So I'm actually probably not the best person to ask about all of those libraries because I'm also not sure I know all of them. Yeah, so maybe if someone in the chat can answer about those, but I know that some of them have definitely Dask integration.
Yeah, and I'm in the same boat. I know some of them and not all of them, so I wouldn't want to answer too much. I know Dask also does have some native hyperparameter tuning solutions like grid search and randomized search and, inside of it as well.
So there was also a question on the link. So here shared also here. That's the link to the slides.
Great. Any final questions before we wrap up? If anybody wants to keep chatting, feel free to jump over to one of the sessions. I know a couple of the Miami attendees expressed wanting to hang out a little bit after, so feel free to jump back into the sessions after this. But if anybody doesn't have any more questions, I think we'll go ahead and wrap it up. Thank you again so much, Nils, for the talk. I think this is great. We'll have the recording available in probably just a couple days, and we'll have that posted. But thank you all for joining too, and have a good weekend.
Thank you. Bye-bye.